Okay, this is container identity. What is the date? February 9th, 2018. And we're going to start out with the kind of discussion of node identity that's on the agenda.
Hey guys, this is Cheng from the storage SIG. The background of this is, so in the storage SIG, we've been pushing the feature of local persistent storage, which has been driven by Michelle, who is also on this call, I believe. And the goal of that is really to make what used to be available through a host path, which is local storage on the node, on the host, and apply better security boundaries to it, and make it available through the existing persistent volume claim and persistent volume abstraction in storage. And the provisioner is there to help automate some of the process. Mainly, it's to perform two main actions. One is discovery and deletion of the local persistent volumes. So discovery is when a user makes some piece of local storage available to a predefined location on the host. The provisioner will automatically create a associated PV with it. And on the other hand, for deletion, if the persistent volume claim is associated bound to a local PV is deleted, the PV will be released, and the deleter handles the cleaning of the underlying disk. And so currently, right now, it's set up as a daemon set where every single provisioner runs on every single node, performing this discovery and deletion process. But one main security concern with that is each provisioner has access to all the PVs, all the persistent volumes, which are API server objects, and even the ones that it does not manage. So when one node gets compromised, it could potentially affect the managed local volumes for all the other nodes. So one big ask, and we've one of the main focuses in the past couple of quarters was to kind of design around the security concern. We have a couple of designs. One major pattern being having a separate master as a central component, maybe running in a separate deployment, which is run on a trusted node, performing this PV modification, and have the other provisioner workers communicate with master. But then there were some other concerns with the communication that could get compromised depending on which design we go with. In the end, we have a design that solves our security concerns, but we're wondering if the container identity work group is planning to have any moving towards a per node identity, so that we can identify every single provisioner in the daemon set, and maybe we can have an admission controller confirming the identity and matching it with the local volumes that it manages, possibly through labels on the PV, so that we don't have to go through the roundabout route of having a separate design just to solve this concern. So any of you guys have any thoughts?
Well, on your current design, or what you're working with, how do you actually authenticate the individual sort of node agents to that central manager?
Right now, we don't even have a central manager. Right now, we just a daemon set and talking to the API server directly.
Okay, but you said you had something that was workable now. I just want to understand sort of what your current status is.
Right. So one possible design is we have a central manager, some master pod running in a deployment. Instead of communicating directly with each provisioner in the daemon set, once a discovery and deletion task is available to be executed, it will create a job, a separate job in the target node. And the communication is instead of communicating directly through messages or some sort of API object, it will report the status through the job status itself. For deletion, for example, if the deletion is in process, the job's in progress. And if it's completed, if it's errored, the job state will report that as well. And for discovery,
callback.
Sorry?
So it's a top-down approach, like the central one pushes out the tasks.
Yeah, exactly. And the jobs don't even report back the data directly. It basically prints out its output in standard out, and the master can go ahead and just read that. And so, in the sense, it gets all the security concerns get deferred to the API server, and API server is a lot more trusted.
Okay, so then the alternative here, you're calling it a per node identity, but really it's per pod because you're still using a daemon set, and you know if you're running multiple daemon sets that are doing similar things, you want them to have individual identities also, right?
Yep, that's what we're looking for.
Per pod per node. So it's it's a daemon set identity attenuated by the node that the particular pod is running on. Yeah, some of the work that's going on around dynamically provisioned service account tokens is starting to include information about the node in the credential, but that is for purposes of revocation. It's not actually surfaced up into the identity itself where you can make use of it in terms of authorization rules or checks.
So there's a parallel here in some ways with stateful sets, in that I think Jordan, you were talking about this as being sort of attenuating the service account per pod, but in reality, if you want to make decisions on it, you have to create a service account per or at least an identity per pod, right? And that's similar to stateful sets where you're actually creating a PVC per pod, right? We've gone from sort of a one-to-many type of mapping to something where we have to manage an array of things if we were going to model it that directly.
I don't know if that's necessarily the case. If you think about what kubelets do, kubelets have these massive powers attenuated by which kubelet they are. So
but they each have their own identity, right?
Yeah, they each have their own identity.
Yeah,
that's how we accomplish that.
Also, like stateful sets, if one of the pods on a node is deleted for some reason in the daemon set model, and a new pod is spun up on that same node, it should ideally have the same identity.
So far we've said that the node attenuation on those service count jobs should only be used for revocation purposes. Is that a hard constraint, or could we service that through extra info into user info?
So Mike, I think that's a horrible idea. And the reason being is that we're moving identity from being like a single string to being, you're going to key authorization decisions based on sort of a grab bag of attributes. This leads us towards the sort of, it's
ABAC. It's used like, I don't know. It's common practice. It's not like a crazy idea or way out there. There's people build authorization decisions based on ABAC.
This would look like, I guess, a special purpose authorizer, like node authorizer, right?
So they are running it in mission is what I heard.
There's a whole ramp of complexity. So you can, if you go down that road, you can start by saying, well, you must have this attribute to have this permission. But then pretty soon, and immediately, you get to the use case we're talking about here, which is like logical comparisons. Like I want to allow this if the value of this attribute matches the value of this other thing, and so now you have like comparisons and expressions and evaluation
that are built into a domain-specific admission controller. which is the admission controller that is handling doing the restriction on the daemon set or the local volume daemon set actions against the API. Generically, I think it sounds bad, but in a domain-specific application, I'm
yeah.
It is ABAC. It's nothing crazy or new or novel.
So
yeah, what you end up with is doing things like writing authorization policy that's broader than you want it to be, and then just hoping that you have the admission plugin in place that's gonna come back after the fact and do these comparisons and scope it down.
So, I mean, one of the things that this challenges is that we've been looking at tunneling all identity in pods through service accounts. When I think about sort of like when we're designing Spiffy, for example, there was the mapping of identities to pods is flexible enough that you could go through and actually offer up identities per pod or per service account or per namespace. There's any number of ways to actually map identities in. And so I think some of the question here is that, and then there's also the question of multiple identities, right? Like, it's not unreasonable for us to say that, hey, look, you can get a service account, which is a generic identity across multiple pods, or we also provide, in addition to that, we provide us a service account or an identity that is per pod that actually has its own namespace, and you can mint JOT tokens on that identity. Not importing Spiffy, but like I think, you know, having a more flexible mapping between identities and pods that doesn't have to tunnel through service accounts would actually get at this.
Yeah, I think you're going to run into there are at least two dimensions where you would care. So there's per pod or per node or per node per pod. So like, and the local volume stuff cares about which node it's on specifically.
But it can always go through and actually refer to the API server to get that mapping of like which pod lands on which node. It's not fun, but it's possible.
Yeah.
So basically,
The whole per pod versus per pod per node, that doesn't really parse for me, to be honest, because pods are necessarily scoped to nodes.
Basically, as I understand it, once you have the per node identity, you can get the node information from the API server in some way, and then you will automatically have the per node.
I think you meant to say per pod for the first one.
Yeah.
All right. So, I mean, so the thing that I think that this makes me want to consider is that right now we've been considering that there's only one identity assigned to a workload or to a pod, and that's tunneled through the service account. I think it's reasonable to also say, and you know, and maybe this can be mixed into the JOT minting APIs to say, hey, do I want, you know, hey, I'm on this service account, can I get another JOT for this? Or, well, no, it wouldn't be. As we build the stuff into the kubelet, maybe we could also provide a JOT that is a per pod JOT.
I'm still drawn to the idea of attenuation. Is there some reason why I'm just wrong? Like if I have my local PV provisioner identity, and then we somehow plumb through the node that you're on through the identity assertion, and then we let you write RBAC rules that say, I can get pods so long as they're attenuated by my node. Like we find a way to represent that. Is that just at its core the wrong way to do this?
It's conditions. I think it's ABAC. I think it's a style of deployed. What was that, CJ?
Sorry. It's very specific to this node case. Like you could do it in the general condition case, but we have built this trace the node graph thing. So if we came up with some set of resources that are node graph traceable, and we said these identities can access these resources so long as they can get there from their node authorizer. So like pods are node graph traceable. So you could say you can get pods so long as they map to the node that you are attenuated with.
It's a kind of different type of attenuation, because generally we've been looking at attenuation of like, hey, I have some powers and I want to downscope those powers, as I hand off some credential to somebody else. This would be somebody else's, it's, and a lot of times attenuation is about restricting what you can do with it. This is actually sort of not attenuation in that sense. It's really about providing sort of an extra dimension of identity to the thing. Right. So I mean, I'm not sure the name applies, but I think the detail is worth. I mean, the idea is worth exploring.
I think I'm with Mike. It sounds like conditions to me. Like I could also imagine like in the future, say you have like, I only want particular workloads to run on, you've like set your taints and tolerations or whatever. So particular workloads are in your kind of secure enclave that all the nodes there have TPMs or something, and you want to have like some sort of confidence that, yeah, this request is definitely coming from a node that's running with a TPM, or has some other like attribute of the node. It kind of feels like once you like break this barrier of like some sort of node identity, then it kind of opens up conditions like that. Like it is a condition, and then there's more that people might be interested in.
So, I mean, so this is another advantage for having the identity control plane be separate from the Kubernetes control plane, in that identity control plane could actually imply extra constraints to say this set of identities will only be served by these machines, and actually have a sort of outside check versus the taints and tolerations and the configuration that's happening inside of the Kubernetes control plane.
I think both of those get us away from the power of the node authorizer, though. If you rely on general conditions, you lose out on being able to trace a request for a secret or for a volume to which pods may be scheduled on the node that also mount this volume.
But again, there's a difference between auditing and having extra data for auditing purposes versus making authorization decisions based on that.
I'm talking about authorization decisions. What were you talking about?
When you said tracing, I thought you were talking about auditing.
No, so tracing is in what the node authorizer does to determine whether it's authorized. So the node authorizer, when the kubelet requests a secret, it actually computes the graph of, does this node have any pods on it that require this secret? And so if you want the local PV provisioner to be able to restrict its access to volumes to ones that are actually required on that node, you need to do some sort of the same thing. Like you don't have all the information present in just the request object that you have at the authorization step.
I thought the scope of the PV provisioner, local PV provisioner stuff was a lot smaller than that actually, and was just wanting to guard write access to the particular local PV resource for that node. It was a much more one-to-one, like only let the provisioner running on this node modify the PV resources for this node. The node authorizer is not. I don't think it's intended to be kind of a generically programmable thing for use by things outside the kubelet. That was a pretty practical compromise, like given that every deployment or every cluster is going to have kubelets, and the scale of what they're dealing with is really large, and kind of manifesting the policy for kubelets was going to just be a ton of overhead. Something like a local PV provisioner where you're dealing with like one resource, and it's a much slower moving set of permissions than let me run 300 pods on 5,000 nodes. I don't know. I'd be more interested in getting the identity pieces figured out. And then I think we have options about how we authorize them.
Yeah, I sort of had my own use of this in mind, that you might want to run a daemon set that has the power to get service account tokens for the pods on the node, but none of the other kubelet powers. So you don't necessarily want to open it up to all of the kubelet permissions, but it would be nice to say that this daemon, this daemon set has some subset of node powers. And that would need to go through something like node authorization.
Again, for like getting credentials, I think the direction we're moving in is much less getting them and more creating them. And so if if you had a daemon set you wanted to run, and you wanted to be able to create service account tokens for the pods running on the node, you can do that with like a single check. Say you're allowed to create service account tokens, and then you have a hook that before it lets you create it for a particular service account, goes out and finds the pod that.
Yeah, but by the time, what we're talking about is using the service account token to actually create new service account tokens. By the time you actually use that credential, you don't know what node it's coming from unless we actually sort of go down the same path, right?
And that's what I'm saying. Like the identity information, including either the pod or the node. I think your case is valid, Joe. That if you have the pod, then you know the node. That seems like it enables a lot of use cases. I do share concerns about how we will write policy against that, like what that ends up looking like. But
I don't think we even need to write policy to solve this specific use case, but the general use case, I would share those concerns. For this specific use case, they want to apply extra policy in admission controller. So all we have to do is surface that in extra info in the user info context. We don't even have to think about changes to the authorizer interface.
Yeah, I think you're right, Mike, for this specific case.
And I think Jordan's counterpoint was that like you're kind of branding broad access and clawing it back with admission, but I don't know, maybe that's okay.
I mean, we do it today. Again, it was kind of a practical, like, here are the tools we have. How can we do the best thing today? If we're looking for a pattern to start recommending to other people, and that's going to spread and never stop spreading, we just want to be careful before we say, yep, here's how you do it. You give broad access, and then you scope it down in admission. Some of the gaps around that are admission only lets you protect write operations, right? So you can't protect read operations that way. You can't subdivide lists. So if you give someone list across all objects, you can't like punch out holes in that and say, oh, you can list everything except these three things. Maybe that's, I still think there's value there, that it's value for like this volume case. But we just want to be aware of the sort of anti-patterns that are in that approach.
What is extra info for, Jordan?
So the things that I've seen it for have been for reducing permissions. So in OpenShift, we use it to plumb OAuth scopes. So all the cases that I've seen have been for reducing permissions. So if you omit extra, you have whatever the permissions are of the user, and extra can attenuate.
We have seen it used as the opposite in Kube, though, like with the OpenShift, the OpenStack authenticator and authorizer was using it to pass additional sort of group-like information.
Yeah, it's typically a way to take an authentication piece and an authorization piece that share known information and plumb it through. RBAC doesn't make use of it. So if you can't write RBAC policy against extra attributes. Actually, none of the Kube authorizers in tree make use of it. So it was essentially a plumbing mechanism for external integrations. So you've got a webhook authenticator and a webhook authorizer, and they can make use of this to plumb either attenuating or expanding information.
I got to be honest, I don't understand the problem with just giving each pod its own identity in addition to any service accounts that are attached to it.
2 identities is...
It's which file do you read?
When you use which one?
I mean, typically folks would use the service accounts that's attached to it, but like, anytime where there's a singleton in a system, it's, I found that it always bites you in the butt. So like plumbing in the idea of multiple identities being available to a workload from the start doesn't seem like a bad idea in general. And this is a concrete example.
I mean, identity as something other than a single value is a little strange to me. Like, who are you? Like, who would you like me to be?
Well, I think, another way to look at this is that we could say the root identity is this pod identity, and then the kubelet on behalf of you uses that to actually, get a token for the service account so that you're impersonating that service account and just makes that available for you. So your root identity is still that pod identity.
I mean, at the point where your identity is the service account, but then there's more information, it still sounds like an additional attribute. And whether it goes in extra or goes as a new group name, or like it's kind of arguing about semantics at that point.
Yeah, because
what I would say is that the service account is an attenuation of the pod identity, or it's a pod identity acting in a role, right? And so the true identity ends up being the pod identity. And so then the extra information in the service account is that, hey, this is actually this identity acting as the service account identity.
I tend to think of that ID token as something a little different. I do agree with Jordan that it comes down to semantics. I think that it is a grab bag of things that the Kubernetes can assert about the holder of that ID token. So the subject we have picked out of convention that it would be the Kubernetes service account, and we will have another field in there called pod, which is the pod name, and the node, which is the node name. But it's basically assertions that Kubernetes can make about the holder of the ID token. I don't know who came first, or if anything necessarily needs to come first to create the chain of the different assertions, or whether it can just be, everything flat. Or maybe we should have found a different way to encode Kubernetes service account in that JOT originally, but it's
this just reminds me of X509, where it's like you have this ordered list of unordered sets of key value pairs. I mean, it just feels like we're taking this idea of identity and we're creating all these sort of nuances on it because we're not assigning identity the most granular thing. But maybe we should even actually have a container identity, and then you can use container identity to get pod identity, use the pod identity to get service account identity.
Yeah, there's already discussions about differentiating permissions between containers and a pod. Yeah, I mean, service accounts had uses outside of containers as well. So there's that to keep in mind as well. So pinning it to a process running in a container, running in a pod, running on a node, like that is a major use case, absolutely. But it's not the only one.
Well, if anybody else is acting as a service account, they should take the identity and actually use that to act as the service account. So if you have a controller that's acting as who else is acting as a service account outside of this? I mean, there are people who go and
controllers, and then like external, CI system. You have give it a service account identity.
Yeah, they shouldn't do that. I mean, it's stupid. Like, we already know that's a problem because now we can't rotate those service account jobs, right? So they should have an identity that's allocated out of some other identity provider that's not service accounts.
I agree. I think that's an anti-pattern that we're sort of stuck with because people use it today, but I think it's the wrong way to have it.
We shouldn't design that in for future stuff. Or like if we want to have a token service, then we should take the Bootstrap tokens, we should generalize those, and then you can use those for doing something like external CI/CD systems, where you have an explicit management of those things, of allocating them, deleting them, and you actually have an audit trail of who actually allocated those things. We don't have any of that with service account. Well, it counts some of it with service accounts now, but it's all very roundabout.
Yep.
So I have another question for the people working on Node local storage provisioning. You said that you were using an admission controller. Can you describe what the admission controller actually does? Does it do any modification of the request, or is it just purely for forbidding certain actions?
We're thinking of using a admission controller provided that we have some sort of per pod identity. So once the admission controller would, what we're thinking is it would take the identity. Once the pod tries to create or modify a PV, the PV will have some sort of annotation on it indicating who, meaning like which provisioner is managing it, and then the admission controller will just verify if the identity came from the provisioner that the PV was created with. And the PV, the annotation is set by whoever creates that PV. Does that make sense? Or?
Yeah, so it's not purely based on, you want to make a decision based on fields inside the persistent volume, specific to that annotation.
Yep.
And will this live inside the Kubernetes code base? Or
This is all external. This is in the Kubernetes incubator external storage repo. So we would have to use some sort of what's it called, admission webhooks in replacement.
So for authorization decisions that require field-based checking, I think the only way that Kubernetes supports this today is to let everything through with the authorizer and deal with it in admission control.
And then what would be the technique to provide that per pod identity then?
Well,
this is okay.
If everybody lets me put it in extra info, I think it would be available to you to make that decision. But I don't know if there will be friction in getting that in.
Mm-hmm.
So I share the concerns. I think adding this kind of like attribute-based thing into the core authorizers, like especially particularly RBAC, like doesn't make any sense, and it's really complicated to evaluate policy with arbitrary conditions. But I think a special case authorizer or a special case admission controller that acts on the pod or the node data feels tenable to me. Like we did it once for node authorizer, and that is small enough scoped that basically it is manageable. And the node authorizer is non-trivial, but it has a pretty well-defined scope. And I think the same thing for this kind of use case.
But should we, I mean, so here's a question. Should we have actually, we didn't do the same thing with node authorizer because each node has its own identity. Each kubelet has its own identity. We're just, it's looking deeper in terms of what's accessed based on data that's stored in it. So like using this data, like when we did the node authorizer and we went to per identity per kubelet, should we have actually picked one identity for the kubelet and then encoded some other extra information, maybe using some alternate names or something like that into the X509 cert, so that we had the single sort of like common name for kubelets, but we actually had the node name encoded in some other way? Because that would be the parallel to what we're talking about here. Is that what we should have done for the kubelet?
Does that only matter for when you're writing policy? I would say it's like, but it makes it different to write, like today you can write an RBAC policy that says only this node can do whatever. I don't know why you would do that.
The parallel, I guess, if we changed service accounts to work the way nodes do, we would give the pod name would be the identity, and the service account would end up in like a group, because that's what we do with nodes now. Is we write policy around node groups.
What's the difference between these attributes we're talking about and groups? Like, why can't these just all be groups on the identity? Or
Well, because the attributes we're talking about take a general identity and make it more specific, right? And groups are a way of taking a specific identity and making it more general.
Yeah, groups are orthogonal and additive. Like if you're a member of Group A and Group B, those can be non-overlapping. They don't attenuate. They don't. The username is the identity. The groups are kind of orthogonal to that, and like I said, typically extra uses I've seen have been attenuating, but they also allow for a single key and multiple values. So I think OpenStack was using that for like the list of projects, OpenStack projects that the identity was associated with.
Sorry, I skipped a step in there, which was if we had per pod identity, or like a more granular identity.
Yeah, exactly. That would be my point. So I'm with you, Tim.
So you're thinking like, so in the new token request API, when we have V2 service account tokens, your token that you get gives you an identity of your pod with groups that correspond to the service accounts. Does that make any sense? I mean, that would be a big change.
Yeah, it'd be a big change.
I consider private claims in that ID token part of the identity of the holder of that ID token. I think we are conflating subject of that ID token, which is a specific claim, with identity. And I think it's an important claim because it is what we have built all of our authorizers on, along with groups. But identity of the holder is all the claims taken together.
So, I mean, so one of the things to keep in mind is that this idea of extensible set of claims is specific to like the JOT way of authorizing, and we have lots of other ways that people, so like if we do this, we have to figure out how do we encode this stuff into X509 certs. How do we actually get it returned from, other types of ways that people are authorizing into the system if we start depending on this more and more?
I think it does generalize. There's a proof of identity and there's assertions made. We can call them claims, which is the JOT in JOT vernacular, but I think it does generalize to X509 extensions or whatever.
Have you tried actually reading X509 extensions? Like none of the libraries support it. It's a total disaster.
Not by hand, but I have written code that reads X509 extensions.
The exposure of that stuff is very spotty depending on the library that you're actually talking about.
I was indicating that we should do it.
So I think one thing that might be interesting. So short term, immediate term, I don't think we're going to switch the identity that a pod gets. But if you look at the doc that Clayton had around how we could start consuming the generated tokens, I think it would be interesting to consider what it would look like to let a pod say, I want a per pod identity instead of a per service account identity. And a lot of the token request stuff that Mike is working on could actually additionally be used to get a per pod identity. So right now we're looking at saying, I want to do a token request against a service account, but it would be pretty reasonable to also be able to do a token request against a pod. And so if you wanted to inject a pod specific token, then the kubelet could go get that instead. And that would likely include some of the aspects like the service account that the pod has, but that could let the local PV provisioner say, I want, in the pods that I spawn, I want per pod information. And then, authorization wise, you still just end up with a username that they can allow through, and then their admission can do whatever lookups that it wants. And you would, like to Tim's point, you could have a group that would say, all of these pods are running under this service account, so I'm going to let that group write these objects and then have an emission plugin that looks at the particular pod.
How is that better or worse than encoding pod name as a extra info field?
I think the amount of structure we can assume in authorization is limited. And so the username as identity and set of strings as groups, that is a small enough amount of structure that you can typically get that to fit into various authorization mechanisms. When you start dealing with extra, I think you break down.
I agree for the authorization, on the authorization side, but this specific use case requires comparing the node name against an annotation in the persistent volume. So for this use case, I don't think it actually is helpful.
Why don't we adopt X509 distinguished names? Because we're just reinventing that.
Can you describe what that is?
It's essentially, you have the common name, but then you actually have the organizational structure, or sort of things that actually essentially become annotations to that, and it ties into directory structure. Because we do have a certain amount of directory structure here, where, you know, instead of OU, we can talk about the service account, and then we can have PN instead of common name, right? Now, this is mostly a foil because I hate these things, but
I think that implies hierarchy that we don't necessarily have. This is more, I think this is more attributes.
Okay, let me X509 explain to you. Actually, distinguished names have hierarchy, but each rank of the hierarchy is an unordered set of key value pairs.
Oh, I know, and Golang doesn't support it.
I know, right? But I'm just saying, like you know, there's two things. There's there's the key set of key value pairs that specify one thing, and then at some point we may want to actually have the hierarchy that goes with it, because it's really, and we already have the hierarchy in some ways because we have this colon separated convention when we give names to things, right? And so we're going to probably borrow that colon separated things to actually specify the different types of attributes that we have on these things.
Yeah.
We've mostly been talking about this around kind of like attributes that are tied to the node. Just to throw out another use case that I could potentially see for something like, you know, attributes on the pod down the line would be the debug container stuff that's coming down the pike. You could, for instance, have a, like, you know, this pod was tampered with by, you know, running this debug container or execing into it as extra info on there. And then, you know, you might want to do something with that down the line. I'm not saying there's a specific thing that we want to build with this, but just kind of throw out a non-node use case for extra annotation, info, attributes, whatever you want to call them.
You could also think about properties of the container image. I mean, as things that potentially someone might want to write authorization against.
I think you really want identity to be immutable. Like it's locational. So something like that, where it's a property that can change over time, that gets really tricky, because then, like, if you got your identity when the pod started up, and then later something happened and that changed that attribute, I don't know that we'd want to start counting on
that's good
attributes of mutable things. Like what we have now is locational. Like namespace and name don't ever change, and they can't change. And if they do change, then you are somebody else. And
well, if we made the root ident, go ahead. Sorry.
Oh, sorry. For stateful sets, right? If we want a identity tied to an instance of a stateful set, that can move to a different node, right?
Right, and so that's why, like, the subject, we just want to be careful about what we choose as a subject. So the subject is who you are, and then you can have other attributes, whether they're groups or extra attributes, that don't change fundamentally who you are.
So another aspect here, and I'm just going to confuse this a little bit more, is that pod names are unique in space, but not unique in time. Really, the identity should be tied to the pod UID. But unfortunately, we don't have a lot of capabilities now to actually index the API based on UID. So it's not trivial to do this sort of UID to pod name lookup. I don't think so. Maybe I'm wrong.
What we do for the secrets today is we look up the secret by name and compare the UID. So that gets you approximately the same.
Yeah, it doesn't let you write policy against a UID, but it does mean that if the particular object goes away and then another one with the same name comes back, your credential isn't valid anymore.
Yeah. For the go bin encoding thing, right? Problem you saw that on GitHub. Yeah, we don't want that.
Right. We're running up kind of on time. I just want to. What do people think is actually the next action here? Like, what do the storage folks want to kind of like? What do you think is your next step here, or what would you like from this group?
Yeah. My biggest goal for coming here is really to understand is does the work group want to solve this problem in the future? And if the consensus to some degree yes, we can basically what we want to do is be able to decide whether or not to move forward with the alternative jobs approach. If there's consensus that the decision is yes, we're going to eventually within the half a year or next year or so solve this problem, then we don't need to go with the other approach and rely on the more generic solution that we come up with here. I'm not necessarily interested in a specific solution now. Just want to know that if this is going to be solved in the future.
So I would say, my prediction would be that within a half a year, either JOTS will have extra information about the node that those JOTS were minted for, right? Or we'll have some level of sort of per container, per pod identity that's going to be available also. I think that would be a safe bet that's coming down the pike. I don't know if other folks agree with that.
I think there's enough use cases that clearly need this level of granular information that we will have to figure out a way to provide it, either by extending what we have or by making another mechanism available. Both for the case of daemon sets, stateful sets, those are the two most compelling ones where you want to run something out on all these places, but then be able to distinguish between them when they call back to you.
But I think we'd like to see this in the audit log also, right? I'd like to audit like, hey, this is using this service account, but under the covers, it's really this pod.
Yep.
Yeah, I think it sounds reasonable. So I guess maybe just to document that, we should have a feature request or something filed so we can have something to point out for this discussion.
Yeah, that would be super helpful.
And I think the stuff Mike's working on is the natural place to put that, because that is starting to include the information we need about the actual use of the token. So, we know this thing is coming in for this node, for this pod. Could even be down to the container level if we needed it to be. But
storage folks, do you think you can write that feature request, or do you want one of us to write it?
I can write a very high level description of what we need. I'm not sure if it'll be generic enough for all the other use cases that you guys are seeing.
Well, this stuff is always more powerful when there's like a really concrete need behind it. So yeah.
Okay, sure. Yeah, I can go ahead and set that up.
Great, thank you. So I don't think we've got Clayton unless he's snuck in and I can't see him in the participants. Does anyone else want to speak to that doc? I don't know, Mike, if you've kind of talked to Clayton enough about it to kind of speak to it or not.
Yeah, I can speak on it. We only have 6 minutes left, so I'm not sure how deep we want to get into it. The idea is what is being proposed is a new volume source that is called the service account token source. That service account token source will be an empty volume or an empty dir that the kubelet will project service account tokens into. The idea is that we can replace the secret volume that we use to inject service account tokens into pods with this new volume source. The motivation behind this is we want to move tokens out of secrets in the API. They present some security and scalability issues. Initially, the tokens that will be projected into these volumes are going to be very long-lived. I think we'll probably pick some arbitrary large number to maintain compatibility with the current service account JOTs. Over time, as we can update client Go to be able to reload ID tokens from disk, we can actually cut down on the validity duration of those tokens. So there's no API spec'd out yet. I think we want to get that out in the next couple of weeks in a proposal to the community repo. But so this is a very early draft. If you guys have any questions or comments, please, or are interested, please check out the doc. And there will be more to come and more formalized proposal in the next couple of weeks.
And the idea is that the admission plugin today that is injecting secret volume mounts as the generated tokens progress and can be counted on to be available, that admission plugin could switch to injecting on-demand service account token mounts. So once the API servers were started with the information they needed to support this token generation, a lot of this could be transparent to end users. Their pods would just start up and have the same things they expect at the same location they expect, but they would be backed by a generated token instead of a secret.
So does anybody have an idea of how many folks take the JOT secret that's in the service account secret and use that like as an environment variable or as a command line flag? I mean, that's probably not a great idea, but it's technically possible. Does anybody do that we know of?
I have never seen it. So I'm sure someone is doing it, but it's
because we would be breaking them with this, right?
No. So they can still the ability to reference secrets that exist as their own secret volume and project keys into things. That would still be there. We're talking about the automatically injected volumes that the admission plugin is adding.
So we're not going to necessarily stop signing the secrets right now.
Okay, so the secrets would still exist.
If you wanted to set up a secret and have it populated with a token, like that would still exist. We just wouldn't. We wouldn't.
That would not be the default way of injecting creds anymore. Okay.
Right.
No, okay, yeah, that makes sense.
So if people are doing things manually, we will support them and can decide how we want to deprecate it, when we want to deprecate it, and over what time period. But
okay, and we could do something like have a bid on the service account over time that's like, hey, do you want to generate your secret or not? And then default that to off at some point.
Yeah. Yeah, but like I said, that's the vast majority. Or minority. I've never actually seen anyone do that in practice. Most of the cases I've seen where people were manually setting up service account tokens were for external system integration, like taking it to a CI system or running a controller with it or something off the platform.
We need a better solution for that.
Yeah.
Yeah, it's difficult when there's no service accounts are the only authentication method you can depend on existing in every
I think it's kind of a problem of like generic pluggability of identity systems, because ideally you want your CI/CD system using whatever identity system it's already using, and then having that somehow recognized. And I think that's kind of why.
To be fair, in a lot of enterprises, they do that, right? Like it's already using LDAP and client certs, and like they already have that hooked up. But if you're writing documentation that doesn't know anything about the cluster that it's going to be in, well, you can't say, oh, just use your Active Directory LDAP credential, and 70% of the internet's going to say, I don't have an Active Directory LDAP credential. And they're like, oh, well, okay, just use a service account token. Here you go.
I think it also mostly comes down to certificates are less convenient to copy paste and to generate right now.
Or revoke.
We're out of time.
All right, let's call it. We're 1 minute over. Thanks, everyone.
Thanks everyone for your time.